So you can now see the presentation. So welcome to this one. It's the 5th one, I think, in line. So for today's agenda, what we want to present to you is like to have 2 topologies or ideas that we would recommend for small to medium-sized competitions. We will talk about the IP ranges or networks in general regarding the IPs. We will also show you some DHCP settings together with how to make a static IP with DHCP reservation. We will show you something about the Windows Firewall. We will explain to you, or at least show to you, how you can test or set the public and private networks in Windows. This is quite a big topic because it can make a lot of issues. Then we will go a bit more to physical layer regarding how cabling works, what sort of cables we know, some small ideas how we can improve everything regarding cabling. Then, yeah, can you see as well? Anya is showing something. I don't know what she wants to explain. All good. And then we will continue to some network speeds, like what is megabyte, megabit, and so on and so forth. We will shortly tell you about the ping option that you have in all Windows, Linux operating systems. We will just briefly show you Wireshark program. Then we will touch the recommended hardware that we are using or what we would recommend to you. And at the end, it will be a demo that we try to prepare something, but you will then be able to ask whatever you want to know. Anya is again showing me something. Is the quality of the stream okay? Hello.
Yes.
Yes, thank you. Perfect. Okay, so this would be the first topology. Up here, what's really important. So again, for small to medium-sized competitions, of course, these are two tatamis. And what's really good is to have one router over here and to have 2 different switches minimum. One switch, it's really good to have for all of the NDI streaming computers for the FairReplay, because all the traffic between them will only be inside over here. And the other switch, I called it switch number 1. It's more for scoreboards and for the servers. Why? Because you don't want that all of the traffic is mixed between these 2 switches if the switches are not really good. It can work, but we don't recommend. So this is our recommendation. Of course, for the rooms that are a bit further away, you run one cable. Obviously, you connect another switch, and then you put all of other computers that you need. Of course, you can have multiple switches. For the internet, try to go with minimum of 150 over 150. And of course, more tatamis you have, bigger internet you need. I mean, faster. If you now just check the topology number 2, you will see that it's almost the same. What is the trick? Well, the trick is that you have a bit bigger switch. You have 10 gigabit uplink between these 2 switches. You can have multiple cables between them. You can do fiber optic. Other thing is it's very good to have LTE over there. Why LTE? So if you don't have the main internet, or if you have some sort of problems with the main internet, this one can take over. Another addition to this one is the VLANs. It's like logical separation on the of the important groups of the devices that you have there. Since this is a bit more advanced, I wrote here that it will be presented in the future webinar or even workshop by Rok. He's currently in Linz. I don't know if he's listening to this talk, so he will tell you more about this in future webinar. Okay, so IP ranges and the networks. First, let's just try with one very simple question. If I give you these 2 IPs, are these the same network or different? So what does this actually mean? It really depends on the subnet mask. I will just open one. I will try to find one of these. I already entered everything here. So what do I want to show you? That it really depends. I will put here too. It really depends on the configuration of it. And this is the net mask. So network mask or subnet mask are the same name for the same thing, different name for the same thing. If we put calculate here, it will say that because we put here 23, these are actually two, it's the same network. It can go from 2.1 to 3.254. So in total, it can do 510 devices. Thank you. So why did I put this here? Because it's really important in the network that you will also see later that you configure it correctly. So over here that you see subnet mask, it's usually like this. So for all of your networks, you usually do like this. What this actually means is how many devices can you then have in the same network? So this is one network. If I just put the default one, it's 24. If I put here calculate, you can see that you can have maximum of 254 devices. Network IP, broadcast IP. This is from, so when you put one router, you have 192.168.0.1. It's really the default one. This is the first device usually on the network. And this is, if you put here 0, then this will be your device, your network IP. Broadcast IP. Each network has one specific address that is reserved. If you put over here, it will be 192.168.0.255. You will see this sometimes. And this is very special address in our network. So each network has this one. And if you send some information, some packet over here, it will be distributed to all of the clients on the network. Then we have these classes. So we have A, B, C, D, and E classes. I will just try to find the notepad that I have all of the links. Yeah, these are the questions. I don't know how to do this now. I did save them somewhere over here. Yes, it's this one. Okay, so if I will give all of the links there. So if you will see here, we have multiple class networks, network classes. So we have, for example, A, B, C, D that's dedicated for the multicast. We can then talk, this is for later, and the reserve that's probably for Army, or I don't really know what. They have these reservations. But if you see here, A, B, C, these are actually the networks that are widely used. So for example, if we go to, you can see here, the green part is bigger. Why it's bigger? Because in the one network, you can have loads of devices here. But if you see the C, it's only the first 3 for the network ID, the last one for this one. So this means what we try to show you here, it's class C type of network, because the first ones are full and the last ones, because it's 0, it's this one, it's green. So this means that one network can have much less devices than the other one. Yeah. This is something I forgot to tell you. Allow. If you will ever see, it can also happen. I don't have IP over here, but it's also possible that something like this, the energy is awesome. Over this, for example, IP, you will think that it's local, but it's not really true. Why? Because even in the C class, you have two parts of IPs. You have some part that it's dedicated for the local network and other that's available for public. So we can actually ping them over the network. Yeah. I will try to find this one. Okay, multicast. Multicast, it's one part of addressing devices on the network. If you have like the TV over fiber optic, it's probably true that you also have some TV station inside your network already. The way how this works is that if you join specific multicast group, you can see live television. So then the next one is what is IP version 4 and version 6. Version 4, you have, I don't know, much less networks IPs available than IP version 6. This one is still in development. In Slovenia, they say it's like really big, but I think only I have this IP version 6 at home from our colleagues. Everything that you see over here is IP version 4. IP version 6, I will just show you IP version 6 sample IP. It's really long string. If you will ever see something like this, numbers, yeah, dvopičia. Column, again, alphanumerical, blah, 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 blah. It's really long. It's supposed to be that every person has like 16, every person in planet has like 16 IPs. So this is to really address all of the devices in the world. Then you have something that's called VLAN. It's something that Rock will, of course, explain, and host names. So each computer on the network, if you run like CMD and write host name, will have its own computer name. It's like pros and cons. So as you will see later, if you will get to this demo, this can be like really good idea, but it can be really bad idea if you have 10 computers with the same host name. So with some really good feature that Microsoft or maybe even Linux put in the operating system, but it caused us a lot of issues. Over here, you will get the PowerPoint. It's very good if you check these links. Also this one, try to figure it out how this works. DHCP. What is actually DHCP? A DHCP is something that when you plug your device into network, it will try to get IP from router. On the right side, I just put a screenshot from the internet. Why this screenshot? Because you can see that the DHCP, what you need to set is like the range on the router. What this means that each router for all of the networks, you can say, yes, for the first 100 devices, so 192.168.0.1 until 100, I want to have like static, so for myself, but from 101 until 200, I want you, router, to be like that you will give the IPs. Network IP, like I told you before, each router has its own IP, and this IP probably gives the network IP. You can change. So for example, you will see that our router is on 192.168.0.1, but if you would like to do it like most of the competitions have 2.1, you need to go to router configuration and change this IP. We just got one bird. I will just close the window. Oh, it's still there. Static IP out of the DHCP range. It's something that we will show you in the demo, but it goes together with DHCP reservation with MAC. There's one very good way how you actually can do reservation that all of the time computer, for example, server is on the same IP. Lease time. What is lease time? When router actually gives you IP, it also says, okay, this is the IP that will be yours for the next some seconds. So over here, if you'll see, there's some maybe default on the routers, it's 1440 seconds. What this means that if you will unplug your computer and plug your computer back in, you will probably get the same IP. If this time will pass and there will be other computers that will connect to network, you might not be able to get the same IP. So they will change. There's something called DHCP exhaustion. it's kind of attack, or it's kind of like problem that can happen in competitions. For example, you have DHCP set for only 50 IPs on some routers, and then you have competitions with 60 devices. What will happen? All of the IPs will be taken, and then when you will connect new computer in, it won't get the IP, and you will have problems. Two computers with the same IP. So if you decide to do static IP and you will go like in a previous screen to this like Windows configuration, you can make yourself a problem. Why? Because you will set two computers with the same IP, then different bad things can happen. That's why we suggest to do all of the IP reservation through the router with the MAC address. We will show you this in the demo. Windows Firewall, it's causing a lot of problems. Why? Because it has so many settings. What is actually Firewall? It protects connections for inbound and outbound. What does that mean? So if you have some server like JudoManager server running, if client wants to connect to the server, this means that the inbound rule needs to be set for out device to connect to inside of your computer. It's really good to know that all of the Windows Firewall have three sorts of networks. It has the domain. So if you have domain server, computer is joined to domain, and different rules apply to this sort of networks. You have private and public. So by default, when you will connect new network inside your computer, on the right side, I cannot show you now, but here will be like one question. Do you trust this network, or do you want this computer to join the network? When you will click on the left side, I know there's no button, but on the left side, you will click yes, it will join private network. If you will press escape or press no, it will be automatically on public. As you will see later, if you have on the public network, you have a lot of problems because most of the program cannot see themselves and you don't really know what's happening. In the demo, we will show you how do you set this thing up on Windows 11 and Windows 10 because they have a bit different UI. Windows Firewall can set rules defined to allow some programs or to allow ports. You will see later how this works, but in general, when you run one program for the first time, it will ask you, hey, packet sender just wants to communicate with the network. They want to allow or not. And when you click yes or no, it will remember that program like packet sender wants to or don't or cannot communicate with the internet. And if you will later see, when you open the FairReplay for the first time, it runs one script. And this script actually defines that ports, some specific ports can communicate inside this computer. You have multiple protocols, or I think protocols, it's a good word, like TCP, UDP. You have a bunch more that you can then see on Wikipedia, like ICMP and such. And these are the protocols that you can configure firewall to. So you can either allow TCP or UDP on port 5000, as you will see later in the demo. There's a question, why shouldn't we just turn off firewall? Yeah, two things, because firewall actually protects you against some things like malicious code running on the network. And if you set everything to off, Microsoft start to be really annoying to, hey, maybe you should just enable back firewall. And when you do this during the competition, all of the rules are actually like applied. And during the competition can happen that you won't have competition anymore. For IT admins, there's this network shell, NetSH, that has like advanced firewall rules. And with this command in the command prompt, you can easily allow, you can reset the network rules, so the firewall rules, you can allow TCP, UDP. it's a good thing to know, and you can put this to the batch file and run it by default when you start the Windows. This way, you're sure that you start with the default settings, for example. I would say that I made a mistake in this one, but it's like common ports for JudoManager and FairReplay. Why this is good? Yeah, it's cool to know that JudoManager is using, for example, server for the TCP. So when you open, I cannot show you now because the firewall is blocked by default. It's actually using the TCP 8888 to communicate with the API that's running for the JudoManager. Scoreboard discovery, it's using UDP that's broadcasting on the 255 on the network and saying, hey, I'm the server, or hey, I'm the scoreboard. The way how you see this for everyone that's using JudoManager, when you are on the scoreboard, and you press settings and then find for the to find the scoreboards, it will automatically appear there, the server, of course. If you have firewall configured wrong, you won't see, so it will be much harder for you. Port 855 on TCP, it's used to get real-time data from scoreboard. So when we connect from the packet sender to find all of the scoreboards, it first listens to UDP 8888. And when you press active, it actually enables, not enables, but it actually establishes connection on 855 TCP. FairReplay server API, it's running TCP 9696. FairReplay, it's using the discovery on port 18918. And to get all of the videos, for example, you need to enable file and printer sharing. That's doing the SMB. So this is on Windows for the file sharing protocol, port 445. In the bottom here, I can also show you, there's one, how would you call IANA? How would you call IANA? What is IANA? International something. So if you will open this over here, you will see that there's a registration of different like services that reserved port number. And if you will go, for example, SSH or FTP, port 21, port 22, or maybe it's here. Yeah, it's not here, like MySQL. You can go through the list and see all of the most important services are listed over here. And IANA, Internet Assigned Numbers Authority, is doing 4 ports and 4 IPs. Like there's certain reservations that then it's not recommended. If you're a programmer and you want to use port 22 for something else than SSH, we don't recommend you this. And you just go to check this IANA for the port reservation. Okay, let's go back to physical layer. Cabling. So in cabling, you have UTP and STP. We have picture here. If you will see sometimes for the STP, it's shielded twisted pairs. You will see that over here, it's some volume. I don't know English word. Volume.
What?
File. Thank you. On this one, these ones are the ones that we usually use. It's like UTP, so it's unshielded twisted pair. And why would you have two different ones? Yeah, because if you have some installation together with very strong electricity, it's better to be more isolated. These ones are heavier, expensive, but for these ones, it's what we recommend for competitions. 100 megabits per second by accident. It happened to everyone. And over here, you can see that this one has only 4 cables connected. Here, there's no cables, and here, no cables. Sometimes when you buy some switches, routers, or some network devices that are 100 megabits, like maybe Blackmagic hub, you will get some cable together with the device. and it can happen that these ones are missing. What this means that you will actually get only 100 megabits per second, and this is very bad if you connect this cable for the FairReplay server, because it won't work properly. Later we will show you one cable that we prepared, and also like speed test and how this cable dies. So yeah, make sure that all of the cables have full 8 pairs connected. What we recommend is like Cat6 cables or Cat5e. I forgot to put 10 here. It's actually 1 gigabit, and Cat6 is 10 gigabit connection. You can connect up to 90 meters. There's one trick. Each cable, I don't have picture, but on the cables, like here, for example, you will see that there's like meters. Each meter, there's one number, and this number is actually saying, it can be indication if you see one end and other end, how long is the cable. One story about elevator. When we were moving to other office, we were checking one office, and the network guy told me there that it happened that sometimes internet there just died, and they didn't know why. And after a couple of months, he figured out that every time someone was using this elevator that's for like very heavy load, the internet died. And it turned out that they put electricity cables together with the Ethernet cables, network cables, and when the elevator was moving, it used so much of energy that it made the interference with the network cables. So network and electricity cables side by side, try to do at least few centimeters apart. So when you're installing cables in the venue. Grounding of the network gear. It's very good to have proper ground. If you will touch one switch, another switch, it can give you a shock. So try to have good grounding, so good electricity. There's one program called Clumsy that we would recommend you to at least install on the server and on the scoreboard, for example. I don't have it here, but this is one program that can simulate bad cabling. It can simulate packet drop. It can simulate like out of order messages. It's really good tool, and you will learn a lot how good network helps you for the good competition. Then we move to the network speeds. We will again begin with a question. You have 100 megabyte big file that you want to download, and at home you have 100 megabits per second download speed. How long will it take in seconds to actually download the file? So basically what happens is that sometimes people mix what it's megabyte, megabit, and megabit is actually the unit that if you would see cable, it would be like ones and zeros, and 1 and 0 is 1 bit of information. But we, like IT people, I would say that we put like 1 byte. It's unit of 8 bits. That's why over here you need to divide everything by 8. And it's really good to understand that you will see it's megabits per second. All of the speed tests are megabits per second. But if you will copy file, for example, from disk C and D, it will give you megabytes per second of the speed. Because of this network, it's always in megabits per second. And on the Windows, files and everything is always megabytes. You can also see notation here. This is capital B and this is small b. Small b, I hope this is correct. 1 gigabit per second. Everybody would like to have this at home. This is actually 1000 megabits per second. So this divided by 8 is 125 megabytes per second. So we have one good quality movie downloaded in 10 seconds. So bit versus byte, I told you. You have multiple tools to monitor what is current usage of the network. Over here, I opened Task Manager and Resource Monitor. I can just do this quickly now. If you press Ctrl, Shift, and Escape, Task Manager opens. And if I put Resource Monitor, this is then the other very good tool. Over here, if you go to the Graph tab, and if I do this like speed test now, speed test. So we will see a spike here now for the receive. I need to accept the cookies. So you will see the graph is changing. It goes up to 300 megabits per second. I hope the stream is still fine. And if you see over here, you go to the network tab on top. You can just click, yes, I would like to know what Microsoft Edge is doing. You click here, and over here, all of the sessions that Microsoft Edge.exe has open will be shown. And you can see directly even to which IP all of the traffic is going. And this is the tool that we use regularly to see, for example, to where are we sending NDI if we have some like Studio Monitor open, and it's a good diagnostic tool that's built into Windows. And then you have other tools such as like iPerf. It's one very common program to do different sort of like load test, speed test, and this is usually installed in the command prompt for the Linux, but there are also binaries available for the Windows. It's like command line tool, and it's much easier to operate, like press up and enter. Windows metrics, for the demonstration, I will show you that you can just print here, out print. If you do this command in command prompt, you will see that it's actually printing all of the routing, so the route table. What this means that if you want to go to 0000, that's the one that if no rule matches here, it will go to this route. But over here in the last column, you have this matrix number. And if this matrix, usually automatic is done correctly, but if the metric is wrong and you have two network cards, and one network card is connected with 100 megabits per second cable, so it's bad cable, it can again cause a lot of issues. So speed test will be lower, network file transfer in the Windows will be slower, everything, you will have loads of problems. Then in the demo, I will show you how you can test how the metrics, so to actually force, use 100 megabits per second, and you will learn something new. And the net limiter, it's one program that's not free, it's very affordable, but if you have very limited network in the venue, and you would see like, for example, to upload during the competition, you can install net limiter. Maybe later we'll have time. And you can say, okay, for this computer, you can just use 50 megabits per second for uploading. OSI model, and on the right, Internet Protocol Suite. It's two really good things. This, if you will go to computer school, computer CS, to computer school, computer science school, thank you. You will most probably learn this. And it goes from bottom up. In the bottom, you have physical layer like cabling. Here it's the transport layer or application layer, how applications are actually talking to each other. Over here, I just opened the UDP, UDP protocol, and over here, you can see that UDP is on the transport layer. it's good if you will have some time, you open this page, it's the second link, and on the right side, you just click through these services. You will for first learn what are like the more that it's below, more fundamental thing it is for the network to work, like MAC address, ARP. If you see the internet layer, what is IP, ICMP, the one that I told you before. So ICMP ping actually works in the lower layer than the TCP or UDP. So I recommend that you just go through this and you will learn a couple of new things. So there's why ping is good, because it's built in the Windows. It was not like this, but now in the newest versions of Windows, it needs to be allowed. I will show you later how this can be done. And this is again the Windows firewall needs to enable pinging for the machine. Why this is probably like this? Yeah, probably there was like you have this program called Angry IP Scanner that I think Elisabetta told us before. And with this one, you can click and you get all of the devices on the network. If you have enterprise network, you have a lot of devices. You can then also see where you can, like with Nmap, you can then brute force. You can then do some bad things. So ICMP, it's now disabled by default. Not the best thing, but it is what it is. It can give you statistic about the timeouts or drop pings. If the ping is good, so if you put -t, but then after certain time you get 1, 2, 3 drops, it probably means that the cable is bad. It might be that someone steps on cable. Cable has like shortcut, and then you lose the pings. So ideally, you don't have any dropping, and in the local area, like in the venue or in office, it should be 1 millisecond. What this means that signal from computer 1 to computer B and back takes 1 millisecond or less. If you have fiber optic, it's good to know that if you will ping inside the country, Slovenia, it's very small, probably it's the same in Germany or bigger countries, it will take 10 milliseconds for fiber optic to ping to go there and back the signal. From Europe to US on the residential network, for example, from our office, it will take about 150 milliseconds. If you will see how networks like AWS towards AWS from Europe to US, it will take 80 milliseconds. They have much higher priority than the residential users. It needs to go through less hops. What is hop? I will just show you. You have trace route. If you put 1111, it's Cloudflare. I will just keep it running in the background. Yeah, this one, it actually tells you, hey, how can I get to 1111 and what are the pings between? And over here, we will see that first we go to our router, then we go to our other router in the office, because this is now the demo network that I created. Then we go to the T2,
service provider.
Yeah, to ISP, to service provider. And here we do the jump. So between the 4th and 5th, we will do the jump. And over here, we go to Croatia, and then we're in the Cloudflare network. It's one very good tool, because if you see the screenshot over here, this means that you will probably have very good connection. So if you're streaming to Max, or if you're streaming to YouTube or whatever, and you ping YouTube in Jest server, and you will have only 4 or 5 entries, this means that you will have very stable. Here on the other side, we were pinging New York City from Slovenia, and you can see that there's a lot of devices for our signal to reach the US. And this can mean that you will have a bit of more of packet loss. You will have ping. There can happen that the traffic is rerouted and you're losing signal. So a bunch of things can happen. And this program on the right side, it's called WinMTR. So Windows Multi-Trace Route, I think it's called. we will add links to all of the software. Now we continue to the Wireshark. So Wireshark is one tool. It can capture network data. It also works in promiscuous mode. What this means that it can get more traffic than it actually that you can actually get to Windows. It runs on Windows, Mac, Linux. You can do different filtering. And why this program? Why do we recommend this program? Well, because even if the software doesn't tell you if the discovery packet arrived, you can at least see it there. So you can do a bunch of testing. You can see if you're getting any traffic from certain hosts. When you will start a program, don't forget to turn it off, because it captures all of the data to memory or to drive, and it can happen that it will you will lose memory and the computer will act funny. We will try to then show you how it looks like, not how it dies, but how the program works. Recommended hardware. So we work a lot with the TP-Link, GL, iNet. They have very good products. Netgear is another one that has one very good switch for 100 or 150 euros. It can do multi-gig connections. What this means? Well, that you can connect 10 gigabit uplinks. You can connect two switches between themselves with 10 gigabit, and you still have one free for example, for the FairReplay. So it has two times 10 gigabit, and the rest is 1 gigabit. Aruba instant on switches. They're really big switches, but they're really good. They don't overheat. They have a bunch of options. They're managed. They're layer 3, I think, even. So you can do a bunch of smart routing. You can enable certain things. So it's like mini firewall in switch. It's not firewall, but it's almost like firewall. We had a lot of successful competitions that were working well with a 30 euro router from TP-Link, 50 euro switch from TP-Link. Most important is that it's not overheating, so don't stack them together. And it's really good to have pre-made good quality cables, like non-damaged. It can happen that the cable looks new, but it's missing, for example, the security pin at the end, and then when you plug it in, someone by accident just moves a cable for 1 millimeter. It's bad connection, and then you have bad competition. Good quality crimping tool and connectors, the ones with the jack protectors. So when you jack protector, what is jack protector? I will just go in the back. This thing in the bottom. So if you have this one, when you will be pulling cable, when you will be cleaning up the venue, the cables, when you will run the cable back towards yourself, the pin won't be damaged. So it's really good to have those on all of the cables. And Fluke Link IQ, it's smiley here because this device costs 2,000 euros, but at the end, it can gives you the report if the cable is capable of 10 gig, 1 gig. If you have some wrong, not connection, but if you crimp the cable wrongly, So a bunch of tools exist, a bunch of software exists to help you create a good network and to help you see what's happening in the network. And now it's the demo time. Here, I will just show you that transition. This is actually our table now. We have a bunch of cables connected. We have 4 laptops. And here on the right is the router. I will now move to other screen. And this is now actually what you're looking at now. It's 4 different computers, and they go from left to right. I'm now on this one. I hope you can see well. And now what I will do, I will just show you this program. It's one very simple program that we made today, because we didn't find any other. Green one, obviously, it's good. It means that we have connection with. I will try. Anya just told me that it's really small. I will try to work with the Windows Zoom function. So over here, what do we have? The computers that I mentioned before, minus that one that you're looking here now, are pinging. This one is pinging now all of the computers. And as you can see, everything is red. I will now go to this computer. So it's the top left one. It's the top left computer. And first, what we will try to do is to just enable pinging over the host name. What do we need to do? Like we told you before, if you go file and printer sharing, I will on here on the left side, there's no green mark. Here you can see that there's no green mark like in the ones. If I hold Shift and press these two, right click, enable rule. Here on this one, we can immediately see that if I ping with the host name, it became green. And this is good. Next thing, what we will do on all of the computers is we will put the network in the private network. How do you do this? I will just try to enlarge this one. Transition. I will go out of studio mode. Now it's this computer, it's a bit bigger. If you're on Windows 11, if you right click over here and you go to network and internet settings, and then this was one question. We don't recommend you to run competition on wireless. It will work, but it can also happen that in the middle, when more people will get there, you will have a lot of wireless devices. It will just crash. So let's assume that you have everything over Ethernet. Let's click Ethernet. Here you will see that this computer is now set to public. Let's put it to private network. I will now go to I will now go to the third one. This one is Windows 10, and it works a bit different. I will just close this one. I will start from scratch. So click on this icon here, left click. You need to click over here. Here I have two networks because I already did one demo before. Let's select the correct one, the one that is connected. And here, let's do the private. And like this, we set now two different computers to the private network. What we recommend is to do this for all of the machines on the network. Go back to this mode. I will just do the same for network. These settings, Ethernet, private. I will disable Zoom. I will do the same over here. Ethernet, private. Okay, like this now we set all 4 computers to be on the private network. Now, the next thing that we will do is we will set static IP for the server, but using DHCP. For this, we will go now to the this one. This is like the third computer. I will open Edge 192.168.0.1. Admin, and it's not admin. Immediately when because before I resetted all of the rules on the firewall, I will show you how do you do this. Firewall. I go to Windows Defender Firewall and restore defaults. If you click this one over here, it will obviously restore all of the defaults, and no programs will be set to communicate by default with the network. That's why now that I opened Edge, it's like the first time when you open computer after format, I will say, yes, you can do some things. I don't know what Edge is doing. I'm logging into the router. It's very basic, 5 years old router. So most of the routers do allow this. I will go to DHCP server. And here, like we were discussing before, of course, router has DHCP enabled. The first IP that DHCP will put out is 0.100 and 0.199. If I just check this computer, here you will see that my IP currently is 0.106. And if you scroll down, most of the routers also show you which computers got which IP. And you can see that IP for my computer is still available for almost 2 hours. Now what I will do is I will go back to server, and for the DHCP reservation, you can do 2 things. So config /all, and it will like this. If I scroll up a bit, it will give you a bit more information about the network card that we have here. One other thing, I will just go to control panel. Network, it's one trick that it's good if you have multiple networks. You can rename and put, if it's working, it doesn't work, strange. So you can rename, if you have multiple cards, you will see on the other computer, you can rename like internal card, external USB card. And when you will see statistics, task manager, resource monitor, it's one helper to help you identify the card that you have troubles with. Now we put ipconfig for all, so we want to have more information, and over here you will see that this is the physical address. So before, when I showed you the OSI model, in the first layer was not the physical, but a bit the second or third one was the MAC address. And the MAC address is a bit lower level than the IP is. And MAC address is something that's also in the packets that are moving around. And this is the way how actually before you get the IP, the DHCP server tells you, hey, you have this address, take this IP. And why am I telling you this? Because it's very important to know that this 8A, A4, C2, F0 to 4, E5, if I go back now to server, to this one, I will see that I also have this one over here. And the TP-Link router, I don't like the interface because they disabled, I cannot select the text. So for this occasion, I have somewhere here MAC. It's this one. And I will say, let's make one address reservation. It's over here, 192.168.0.2. Most of the time it would be 2.2, but I forgot to change this before. So let's try like this. So it's 0.2. In description is server. And I would like to enable this entry. I click OK. What happens now? So I did address reservation, but of course I will now move back to the server. I will just type ipconfig. The IP is still the same like before. And why is this so? Because it kept the reservation. So this computer doesn't know anything on the router that we changed to be a reserved IP. What we will do now is ipconfig release. So now we release the IP. You can check again. There's no IP set to this Ethernet interface. And now I will just do renew. Okay. It takes some time, sometimes. Before, when I was testing, it didn't take the time, but it will work. So for example, if you just move to the fourth one, you can already see that 0.2, it's already active. So it got 0.2 address from the router when it renewed the IP. I hope this sounds logical. Now I will go back to this one. And the next thing that we have in the demo is I would like to show you this one. Yeah, I will try to like this. It cannot find the server. Why is this? Because the firewall is not set on this one. And now I will show you just live how to create a new rule. You need to know that by default, when you install JudoManager, all of the rules are set, of course. So in case that you delete all of the rules, or I think set default ones, the rules might be deleted, and you can add them like this or reinstall the software. Anya, is there any button to do this? No, not yet. Okay. Now what we will do is I will set one port rule, and I will say, yes, I want UDP on 855 and 8888. Next. Yes, I would like to allow the connection on all of the networks. Next, let's put the name 85588 UDP and press enter. And immediately when we created the rule, Microsoft and Windows Firewall start to allow these packets inside the user space. So the network card always gets the packets, but the Windows Firewall then doesn't let them through to the application. And like this, we configure now the confirm. And now I will show you the next problem that we have here. If I have server over here, I can see that this one is red now. And again, I will go over here. I will create a new rule. I want to do with a port TCP, because before we said that's running on 8888. I will also put 855. Allow the connection, TCP, enter. And immediately when we set the firewall rule, you can see that there's a green light over here. And if we go also to this computer, on the top right, usually you see the green icon and it's connected. So what we try to show you here that computers between themselves, they have multiple ports that they try to connect to with either TCP or UDP. And sometimes can happen that one connection can be let through, but other will not. And this is very common, and what is usually the symptom that only half of the things are working. And many times we figured out that it was either the firewall rules were not set correctly, or the networks were set to the public. So I think key takeaways here are that try to understand that the good equipment, so that it's not broken, it's not overheating, that you have good cables, and that you know how the network is configured. Try to go to a router and see how these settings are done, and that you understand that computers needs to be set to private and how at least a bit firewall works. These are the key concepts for you to understand how network is doing and even to diagnose the problems. on the network, because in the last couple of events we had a lot of troubles. And if you follow these steps, you won't have problems, we won't have calls, and it's going to be win-win situation. I don't know if I have just one more software that I would like to show you, and it's called the speed test. Why this is good? Because you can do speed test not out of the venue, but it's also good to do speed test inside the venue between two computers. And I have this one running here already. Yes, I'm sure. I will just show you that. I will close this everything. So this is the program that you can search on Google. You download it. It's on download. You install it, and then in the new Windows you don't find it. Speed open speed test. Yes. Then you will run the program again, because I restarted everything. Oops. So I now just ran the program, and it's very simple actually. And this is how it looks like. It gives you that on this IP, so it's this computer's IP, of course, 169 at the end. On port 3000, we have speed test server running. And of course, if you will open this on the local host, the speed will be quite good. I will close this one now, and I will open this on this computer. And you just open 192.168.0.93,000. And now we will test what is the speed test between these two computers. And as you can see, it will be 1 gigabit connection. You can also see the jitter is very low. Try to have this sort of speeds on the local network. So usually what you can do is, if you have a cutter, just install the software there and go through the devices on your network, like Tatami 1, and you can test the speed test between Tatami 1 and cutter. And it should be almost 1000 megabits per second or 1 gigabit per second. I will just show you that over here. I will skip. I will move we have this very bad cable over here. It's missing a few. It's missing a few cables, because on purpose we not disabled, but we cut a few lines. So if we go back to now to server, to computer number 3, what I will do now is I just plugged in this bad cable in the external card. And if I go now to control panel, network and internet, like this, change adapter settings, you will see that I have 2 network cards active. One is 1 gigabit. This is what I renamed. It's working on this computer, and this one is 100. But how do you know this? It's actually, you right click and see status. And over here, you will see that it's 100 megabits per second. It can happen that cable looks really good. It's new cable, but it's broken. So what we recommend, at least for the ones, the machines that do a lot of transfer, all of the Weverse server, the FairReplay server, cutter, that you check the network connection is actually 100 megabits per second. I don't know how can I show you this, but I know how I can show you. I will go back to this one, and I will, like this. It's a bit slower zoom. Over here, you can see that there's orange light where the cable gets in. If it would be 1 gigabit cable, it would be green light as well. This is one very good indication to know if the cables are 1 gigabit or 100 megabit. Maybe if I zoom here, yeah, this is the switch. And you can see over here that I cannot, I don't have laser pointer, but I have finger pointer. So this one is actually the bad cable, and it's only orange light. And over here at the beginning, you have green lights. And these are very quick indicators that the network cable is 100 or 1 gigabit per second connection. And now I will just show you the last demo. And I would like to show you how the metrics are working. ipconfig. So if I put ipconfig, you will see that I will just disable this one. It will be a bit easier to see, I think. Okay. We have only 2 network cards. In 1 gigabit, because I renamed it before, it has IP 0.106, and this one also got IP version 6 that you can disable, but this one is 114 at the end. If I put route print, I will see that if I would like to talk to my network, like local network 192.168.0.0, it will first go through 106, which is the faster, and 114, that's the slowest, 100 megabits per second. Now I will go to just tell you how do you force. So if it's other way around, that Windows decides that you have 2 1 gigabit connections, and then in the middle, one cable it's damaged, you can force that you go here. I need to zoom. So I will click again. So right click on the network card in the control panel, you go to properties. This one opens. Double click on IP version 4. You go to advanced mode. And on this one, that's now the slowest, we will put 150. Okay, and now I will go to 1 gigabit. And I will put advanced. And this one I will put 200. So bigger means lower priority. Thank you, Microsoft. I will put OK. I will disable zoom. I will again print route print. And now we can see that we have these 2 things. But I'm not sure why it put like this. Okay, nevertheless, let's just try the speed test. Yeah, as you can see, it's 100 megabits per second now. And now what I will do, I will just disable, I will unplug the bad cable. Now I unplugged it. I will refresh the page, hit start. And now it automatically, of course, because the bad cable is unplugged, it went back to the fastest speed. Now we have this last thing, which is that some of you had a couple of questions. I will go now to the 4th screen. Is it possible to use other IPs as long as they are all in the same range, or is it necessary to use the IPs listed in the manual? You're free to use whichever IPs you want. We would recommend that you actually do the reservation, so it's much easier to diagnose. Don't do static, or you can do static, but really make sure that you don't have 2 computers with the same IP. But IPs can be defined by you. All of the software that you are using in terms of JudoManager or FairReplay are dynamic, so nothing is hard-coded in. Is it possible, as in other programs, to have an IT with main server and secondary IT? Do you mean network connected, network card, or what do you mean by IT? I don't know who asked this. if you can write or the overview. So if Jesus is here, he can explain what he thinks, but it might be that this is network card, main server and secondary IP. Yeah. So will you ask? Yes. We can hear you. Now we cannot hear you. Okay, let's move on, and you can ask in the chat. I'm interested in basic network settings for all competition. I'm so not sure if we, but requirements about for would we have. I hope that we did show you a bit information about the firewall, but if you have any specific questions, please do ask. Whatever questions you have, please do ask them. We are happy to help. Good network monitoring tool. I think Nico wrote this. Was it the Win MTR? Okay, I think so, which is useful to run and keep an eye. Or it was G-Ping. Nico, if you can please respond, that would be helpful. Many thanks. Thank you. Can we use 100% Wi-Fi connection? So 100% Wi-Fi connection, I think, doesn't exist because it can happen that you will get multiple people around you with some sort of wireless device, such as watch or mobile phone, computers, and it can happen that they will jam the signal, or now with the mobile hotspots. So we don't recommend. If you have very small competition with 100 competitors, it might work. I know that in Slovenia they are using this, but we do not recommend. For the streaming connection, I don't know exactly what do you mean by that. Maybe it was the speed or something. And the connectivities, I hope we did explain you how to connect the things. So we can now wait for the questions to arise, or we finish. Anya, and today, your opinion.
So,
So,
do you have any questions, or are you happy with the explanations?
I will put back to preset number 1.
Sorry, it's always me, as usual. Maybe the less shy one.
Mm-hmm.
It was interesting to listen to all these things. Of course, in the small events where most of us are working, I mean, not in the big Grand Prix, Grand Slam, or World Championship, the number of computers that we are using and can be easily found without doing so much on naming and renaming and founding the networks and so on, because I don't think the majority of us is so much deep into the networking. Plus, what is the cabling is not on our hands, so we can keep an eye on it. It's always good to know and to know where to go and find. But unfortunately, cabling is most of the time not us doing. So, and we know the quality of cables, the quality of the maintenance of the cable is really different from country to country. And we cannot ask for, we would like to ask for the best of the qualities. In some countries, it's not possible to have this. We had to face the reality because it's not everywhere Japan. When working around the world, we have to maybe lower our expectations, let's say.
Yeah.
We
No,
will need to know, we will need to know what to do in case of failure or one thing or another.
mhm.
But about the quality of the whole structure, it's not always possible to have the top. This talking for the audience, if I can see, and most of we know each other, and we work on the places, and I think the other colleagues can give their own opinion on the thing. This, of course, in a lab perspective, this is the perfect paradise where you have the time to do all the things. Most of the times we arrive very late. We cannot even not check the network before the start. And in many events, it's only one person, two person working. So for everybody, be just calm and relaxed and try to figure out if you have problems, or that's it. We would like to hear from the others something.
Yeah. Thanks, Elisabetta. Again, I'm not nearly as knowledgeable as Simon is about all this, but I work in control room most of the weekends, and we were trying to cover the problems that we often encounter. So what should be checked on the networks, because we've sometimes it happened that, you know, it's difficult to search for the reason why I cannot see this, why is this a problem, and so on. So basically what we were
I perfectly agree
yeah.
on the explanation and all the points. Unfortunately, our colleagues on site cannot always be 100% on all the aspects, and it's not even not their own responsibility to check all these parts.
Yeah, but what, you know, when we come to the problem that you know, you cannot see the scoreboards, scoreboards don't see the server, packet sender doesn't see the scoreboards. So the main issues to check is the cabling okay? Then, you know, firewall, we often say, can you please check firewall? And we try to explain where in the firewall could be a problem. Then, you know, do you have IPs? And maybe one thing that Simon didn't show, it could be a problem that you have two computers with the same host name in the network, and then, you know, it doesn't work. So we try to cover how you can check this and how to address this issue. So there is a little bit more information when you come on the spot. So I know for me it was a lot. I don't know all these things that Simon explained, but, you know, what we are thinking is to give you this information, to also give you the links. Like you said, in PowerPoint, there are a lot of links to the sites where you can search a bit more about this. So for the people who are responsible for cablings, for example, in the European or continental championships, not just European, all continental championships, that it's easier to diagnose the problems, because often even in control room we can connect to the computers, but sometimes it's much easier, especially with the cables. If cables are a problem, sometimes, you know, it's really difficult to diagnose the problem from distance. It's much easier to diagnose it on the spot in the sport hall. So what we try to do today is give as many informations what can be checked and what can be done to see if there is a problem. Normally, you know, if you set everything,
it was not to have our colleague too much scared of all these.
That's what I tried to say. Like
sometimes all these things are not needed, huh?
No, the idea is, like Simon said, programs, for example, JudoManager is made so when you run the program, the firewall is set so the scoreboard should see each other. But if you have reset the firewall, or, you know, do some updates during this time and this happens, So how to check the firewall connection? But normally, when you connect everything, this should happen, you know. And then again, sometimes we say, oh, they don't see, and we say, did you set the networks to private? So we want to explain what means public and private and things like that. But you know, to diagnose where the problem could be and how to set the networks, how to search a little bit what could be an issue. So I hope we answered all this. Not all, but the main issues that can happen. So it would be really helpful to, if you have any questions, or even you know, later you can write if it was clear enough, or it was too complicated maybe, or you would like to have some additional information. But normally, what we are thinking is that the person who is running JudoManager, for example, it's usually not the same person who is doing the cabling. There is usually some other person who is responsible for the network setup, but you know, the person who is responsible for network setup, it would be really good to have a knowledge about the things we discussed today. Deeper knowledge. Not the person who is running JudoManager program, but the person who is responsible for network setting. So if we are clear enough about this. So thank you, Ili, again for input, and I hope someone else is encouraged to ask if there is any more questions. If not, we will finish.
We will disconnect the cable.
Yes, we will finish, and I hope you have some more insight about the extent of knowledge that it's good to have. So there are a lot of links in the PowerPoint where you can get additional knowledge about details about network setup.
And to get you interested in this sort of things.
Yeah, because it's a huge branch of IT, and especially with all the signals and the informations we are sending in the networks, it is good to have some more knowledge.
I guess that's it. Time to say goodbye.
Okay, we will send all the informations again, like usually, and the video from last week we will also send, but we were short on time, so we will send them both together.
Mm-hmm.
I hope that's all.
Tomorrow. Try to expect tomorrow. That's it.
So thank you again.
Ciao.
Ciao.